Alright, welcome to section 2.3, where we are going to be extending our idea of modeling functions, more specifically linear functions. These are kind of our real world situations that we look at, and not necessarily do we always write it as a function, but the idea of solving it, sometimes you are using algebra and not even knowing it. So let's look at this first example. It talks about Emily saved up $3,500 for her summer visit to Seattle. She anticipates spending $400 each week on rent, food, and fun. How much money will Emily have left after 3 weeks? Now, it doesn't specifically say to write a function for this. We could write a function for this, in which we are looking at kind of what is the changing value here. Well, the rate of change that we have, kind of hone in on that each week. When you have a rate going on, it's going to be each week per year, dollars per ounce, whatever the case may be. And that is going to be, in disguise, your M. This is our rate of change. So when we talk about linear functions, remember, we're going to kind of look at something of the form f of x equals mx plus b, where you have a changing piece and you have a fixed piece, or an initial fee, or an initial starting point, like what we saw in section 2.1. So if we were to kind of look at this, and I wanted to figure out what is the amount of money that I have left, what is the output that I have, well, I'm starting with $3,500, and that $3,500 is going to be decreasing, or I'm going to subtract from that each week that $400. So $400 the first week, $400 the second week, $400 the third week, etc. So that is what is going to be changing. So if I said I were to do it in 3 weeks, then we would multiply 3 times the 400 to figure out how much it's going to be decreasing by. So in a generic sense, we could write it like this, where I have minus 400x, where that latter part there is what's the piece that's going to be changing. So here's a function that models that. Now, you might also write it as f of x equals minus 400x plus 3,500, and that would be exactly the same thing. So for what we are asking in this particular problem, what we are looking for technically is what we refer to as f of 3, and we can now plug 3 into our function for wherever I see an x. So I would do 3,500 minus 400 times 3, and you might have gotten to this point without even writing that function, and that's okay. You have the idea or the mindset of that linear function. So that 400 times 3 is going to be a 1,200. When I subtract that, my final answer after 3 weeks is that there's $2,300 left in her account. Okay? All right, very good. Let's try the next one. The idea of linear functions. Sometimes, if you recall, what we were doing in section 1 and section 2 is that we were writing the equation using points. So many times in real-world applications, you can actually take out the information and write them as points. So we're going to see that for this one. It says that in 2010, a school population was 1,001. By 2014, 4 years later, the population had grown to 1,697. Assume the population is changing linearly. So that means we're going to be able to model that using kind of that f of x equals mx plus b form, okay? So we are asked to find an equation for the population P of the school year T years after 2010. Now be very careful if they designate some variables for you that you recognize and read all of it, because this is going to play in whenever we account for our T. So our starting point is in 2010. We're making that like year 0. So if I were to kind of come back to this bit of information, and I want to create some ordered pairs, I can create 2 ordered pairs if I choose, so that I can model the situation that's at hand here. Okay, so I'm going to do 2 different ordered pairs. And again, since this is the T years after 2000, well, on 2000, we're acting that as year 0. So I can do year 0, our population was 1,001. And we're just in the back of our mind knowing that year 0 is 2010. Now for 2014, how many years after 2010 was that? Well, that was 4, and its population was 1,697. Now notice I have the time increment on the x value and the population on the y value. Most often when you're dealing with time, that time will be your input or your x. Okay, this time they're going to call it t, and our y they're going to call it p. So we're going to figure out what is that equation to model this situation. And what we have here are 2 points. From 2 points, I can find a slope, because if I have to write an equation of a line, that means that I need a point and a slope. So I have 2 points, and I have more specifically a nice point here. That's actually going to be with an x value of 0. That point is going to be our y-intercept. We just talked about that in section 2.2. So if x is 0, that means that's my y-intercept. If y is 0, that's my x-intercept. Now, from these 2 points, we can now find m. We, from section 1, had a formula that said I take the y value minus the other y value all over. If I started from here, subtracting this direction, make sure you come from 4 and subtract 0. And when I do that, 1697 minus 1001 is 696. 4 minus 0 is 4. Therefore, the rate of change for my slope, in this case, it would be people per year, your population per year. That's kind of the unit that I have there. And so my slope is 174. Now, trying to figure out a formula or an equation. This time I'm going to do my population in terms of time. Is found by taking, we're going to do this mx plus b, or my slope times my t in this case, plus my v value. So here is m. Now drop the unit there. So I would have 174 times x, but remember our input this time is time, so we can use whatever letter we want. And then add on to that the b, and we just discussed when x equals 0, that is my b value. Therefore, that would be my function that I need for this situation. And once we have that function, we can start plugging away values, doing what we call interpolation or extrapolation, where we are projecting things between 2010, 2014, and we're even making projections past that. So I want to look at, use your equation, and we want to predict the population. So we're looking for P of the school in 2023. So they're giving me T here, but be careful. Remember, T is the years after 2010. So if I'm in year 2023, how many years past 2010 is that? Well, I would do a nice little subtraction here. Therefore, T has to be 13 in my formula. And once I have that formula, I'm going to take that 13 and I'm going to plug it right into where my variable is. So we're looking here for P of 13. It's found by taking 174 times 13 and adding on 1001. Now, by order of operations, we must multiply first and then add. 2262 whenever I multiply, and then when I add gives me 3263 people would be the population of that school in year 2023. All right. Now, the next question is, be careful, it asks now what year. So I'm looking for T now. Did the population reach 2393? So this time, instead of giving you the input value, we are giving you the output value. So we end up having this be my population. So that I'm now going to plug on the left-hand side of my formula and say, okay, 2393 is my population, and that's found by taking 174T plus 1001. I can now solve that equation in 2 steps for T to find the time in which that occurred. So we're going to isolate T by first subtracting 1001, getting rid of that. And I'm left with 1392 equals 174T. Then I'm going to divide by, running out of room here, 174 both places, and I get T to equal 8 years. Now, in year 8, was that population 2393? Absolutely it was, but what year does this equate to? Remember, that is the number of years past 2010. Therefore, the final answer that you have to designate is in year 2018. So please make sure you go back and answer the question that they are asking for, and you might have to interpret the number that you get from the equation to be able to do that. All right, very good. Moving right along. Inevitably, you will have some of these situations where you might have a problem where it says, which is better? Which is the better situation? And here's an example of that. Jamal is choosing between two moving companies. First, we have U-Haul that charges an upfront fee of $20 for you just to rent their truck, and then it's 59 cents a mile. The second company, Budget, charges an upfront fee of $16, and then it's 63 cents a mile. And we want to know when U-Haul will be the better choice for Jamal. So we're going to first write an equation, and then we're going to, if you wanted to, you could actually graph that to see that which one is better, and eventually it will kind of become the one that's cheaper in the end. So if I look at U-Haul and Budget, the cost of each can be found. Well, let's see. If I were to do U-Haul and I were to travel 100 miles and rent that truck, what would I do in that situation? If I have $20 up front and then 50 cents every mile per mile, so remember that's kind of a rate of change that is changing, that we're probably going to be multiplying by those number of miles to get the cost, and that's exactly what we would do. We would take 0.59, now make sure you make it a decimal, multiply that by the 100 miles that I just made up, and then add 20 to it. So if I generically put in, say, an M for the number of miles, and then multiply that by 59 cents and add 20, that gives me a formula that I can use for that situation. Likewise, we have an upfront fee of $16.63 a mile for the other company, which means that I would take that 0.63 times the number of miles and add on 16. So those are my two linear functions. And again, use a specific case if you have to get you thinking about what I would do to find that specific case. Then take that number out and put generically in your variable. Now, it wants to know when U-Haul is the better choice. Well, up front, what do we know? I can see that if I let M equal 0, I don't drive anywhere. Both of these terms are going to go away. 20 is bigger than 16. Therefore, U-Haul is more expensive at the start than the Budget. Eventually, though, these lines are going to cross. So I end up having something like this being U-Haul and this being Budget. And so at some point, they're going to be equal, and then the U-Haul is going to be cheaper than the Budget. It's going to be smaller than that, okay? So let's go ahead and just find out when they are equal. If we find out when they are equal, that means I have to go more than that for the U-Haul to be cheaper. So if U-Haul is 0.59 M plus 20, we want to set that equal to 0.63 plus 16. Whoops, I forgot my M on that one. And then we want to solve that. Okay, so let us do the math with that. Now, you can do all kinds of T-charts if you want and figure out what that is, but that takes a lot more time than just solving straight for that. All right, so I'm going to end up having that gone. Those subtract out. This is going to give me a 0.04 M when I subtract. Now, again, I'm going to get rid of this 16 by doing the opposite, bringing it to the other side. This gives me a 4. And now I need to solve for M, so I'm going to divide by the number next to the letter. And when I do divide, it actually comes up to, I didn't intend to, but it ends up coming to the exact specific case that I gave you earlier. So 100 miles would be when they're equal. So actually the answer to our question would be, when will the U-Haul be better? When we drive more than 100 miles. Okay, so that would be kind of our final answer there, the determining piece, maybe. There we go. Okay, so please make sure that you account for that and that you make the adjustment to the answer if you need to. All right, let's turn to the next one. The next one is talking about median home values in Mississippi and Hawaii, which are adjusted for inflation, are shown below. Assume that the house values are changing linearly. So we're going to be able to put a linear function on there, y equals mx plus b, if we so choose. Now, the median home value, that's just like the middle. If you were to line them all up and find the middle, that's what the median is. Which state has home values that are increased at a higher rate. So again, anytime you see a rate, you should be thinking about what is the slope, okay? That's really what they're asking there. What is the slope of that? So for Mississippi, year is going to go with both Mississippi and Hawaii. So you might want to think about these as kind of being ordered pairs like this. And you can use your slope formula for Mississippi to find the y minus the y, 71,400 minus 25,200, and divide that by x minus x, so 2,000 minus 1950. Y minus y over x minus x. So if we do that, and this is where you want to pick up your calculator, unless you want to do all of it by hand, 46,200 divided by 50, and that comes out to being 924. Now in this case, what do we have? These are values. So these are actually dollars per year that I have. So this is $924 per year that it increases. Okay, so that is our slope there. For Hawaii, actually let's do this. Let's change the color just so we have it. Okay, so for Hawaii, we would take this y minus that y value. Then I'm going to take this x minus that x. So let's go 27,700 minus 74,400 all over our 2,000 minus 1950. And when we subtract the two numbers on the top, 198,300 all over 50. And hopefully just by the size of the numbers you realize and can see that this is $3,966 per year that it increases. Now, which one goes at a higher rate? Definitely the Hawaii does, okay? So the answer to the first question, Hawaii would be the one that goes at a higher rate. Now, we might be able to use that information in the next couple problems. So in part B, it says, if these trends were to continue, what was the median home value? So we're looking for the value in year 2000 or 2010. Now remember, when we have time, most of the time that's going to be your x, and in this case the value is going to be our y. So in order to answer that question, it would be very nice if I had a formula that modeled the median value for Mississippi. So the question would be, can I write the equation of the line that models for Mississippi? And the answer is absolutely we can. So I'm going to stick with the right same colors, let's say. So for Mississippi, I need to have a slope and a point to be able to write the equation. Well, I have that. I have my slope here, and I have a point. Now, I'm going to choose the smaller of the two just because that's the one I picked first, okay? But you could pick the other one if you so chose to do so. Okay, now as a reminder, y minus y1 equals m times x minus x1. We've had a lot of practice on this out of sections 1 and 2. You can write the equation of the line. Now it's going to be bigger because the numbers aren't as nice, but we can still do it. All right, come back here and get my y value of that point. So y minus 25,200 equals my slope, which we found to be 924. Times x minus the x value, which was the year 1950. Now, before, we had that problem where we were talking about since 2010. That's what our time was represented. We're not doing that on this one. This one we're using the full year, and that's perfectly okay. That's why I said be cautious about what you are given in terms of the letters. So let's go ahead and distribute, because we're going to get y equals. So we're going to distribute 924 to get 924x minus, when you multiply 924 times 1950, you get 1801800. Okay? Now, we're one step away because I have to add this 25,200 to both sides. Now be careful, that larger number is negative. So add 25,200. So our y equals becomes 924x minus 1776600. And that right there is my equation modeling the median values of the homes in Mississippi. So once I have that, I can, if I had a when would a home value be certain amount, you could be putting any number in here, solving for x, which is your time. Or for any year, I can then kick out any median value, and that's what they're asking for here. Put the time in for the x. That was my x. I would do y equals 924 times 2010 minus 1776600. And that's going to give us, when we multiply and then subtract, that's going to give us our final answer. So when I multiply this out and subtract that off, you get $80,640. Glitch there, okay? So, does that make sense? In 1950, 25,200. In 2000, 71,400. It went up. And in 2010, it should go up from 71,400, which it does. Therefore, that is a reasonable answer that we would be okay with. Okay? All right, let's try this next one. The next one says, if we assume that the linear trend existed before 1950 and continues after 2000, the two states' median values will be equal in what year? So when will Mississippi equal Hawaii is what they're asking for. And if they're asking when and what year, we're looking for X, putting the Y's equal to each other. Now, that's fine and dandy. Excuse me, I have part of that. That 924x minus 1776600 is what I have for Mississippi, but we've yet to do that for Hawaii. So let's change that by finding that equation for Hawaii. We're still going to do y minus y1 equals m times x minus x1. That's perfectly okay. Now let's scroll back up here. As a recall, m was 3966. And I'm going to choose one of the numbers. Again, let's just choose 1950 and 74,400 just because it's smaller amounts. Those are the numbers I'm going to use. So this is my y value, this are my y1, this is my x1, and that's my m. So let's plug that in. So the y1 was that, whoops, let's go back to red. Okay, so we get y minus, the y value for Hawaii was that 74,400. Equals our slope, which was 3966 times x minus 1950 for that year. Just as before, we're going to distribute. 3966x. When I multiply 366 times 1950, I get 77,33,700. 7,733,700. And when I add this over, reminding you, you have a negative here. Be very careful when doing that computation. We end up with an equation of 3966x minus 765,900. When you do this minus of this number plus the 74,400. So that is the other equation that we have, and that's the median value for any year in Hawaii. Now, that's what I need for this piece of this equation to answer the question as to in what year were they equal. So I'm going to put 3966x over here minus 765,900. And now I have a linear equation to solve, okay? I'm going to subtract the 924x just to make sure that this piece here is bigger. Right here, when I subtract that, that's gone. So that would mean I would have to add this number over on this side. And so then, what do we get? Well, first off, this is going to go away. When I subtract these two, I get 3,042x. And on the left side, I get 5882700. And then I'm going to divide by 3042, divide by 3042, which gives me the number next to the letter. And then x is equal to 1933.8. I rounded it to one decimal place. But how do we answer the question? It said the two states' median house values will be equal in what year? Do I express years with a decimal? Absolutely not. Therefore, I need to kind of truncate that because I'm not in year 1934 yet. I'm just still in 1933. So that would be my final answer for that. Okay, so make sure you interpret your answer as to what the equation or the question is that they are asking. All right, very good. This is our last problem, and it's a very good problem, actually, to be able to mold some of the things that we did out of section 2, along with some problem-solving techniques here in section 3. Now, it says to find the area of a triangle. Goodness, I'm going to have to take you back to geometry a little bit. That when you have a triangle, call it with some base from here to here, and some height, the area of a triangle is found by taking 1/2 base times height. So what we have to do here is to find B and H of the triangle that they are describing. Now first it says that we're going to be bounded by the y-axis. That means this guy here, okay? That is one of my boundaries. I'm also bounded by the line -1/3 x plus 8. So if I were to graph that, what we just did in section 2, we had to start with our B, and go up 8 on the y-axis. Then that slope, if you remember, I could do that as -1/3 or 3/-1. Either way works. -1/3 gives me down 1 and over 3. Down 1 and over 3. And I can keep doing that as far as I want, and then draw the line that I need. Okay. Now, that's part of what I need, but here we also are being bounded by the line perpendicular to our function that we just drew that passes through the origin. Therefore, that is B. That origin is B. Now, if we ask ourselves what is the perpendicular slope of the original slope that I had, from section 2, you had to remember on perpendicular lines, they have opposite slopes and more specifically opposite reciprocal slopes. And so you can't just use the same number. You have to flip this and change the sign. So if I flip that, I get 3/1. If I change the sign, I get a positive, so I can reduce that just to a 3. Okay? Now, with M and B, we can write the equation for our perpendicular line as y equals mx plus b, which is still just y equals 3x. So this is the equation that I have for my other line. Let's graph it. Goes through the origin, and with the slope of 3/1, use it as a fraction. You go up 1, 2, 3 over 1. Go up 1, 2, 3 over 1. And you can draw that line and now hopefully see the triangle that we're talking about. That triangle that we are talking about is this one that goes from here to the origin, here to here, and here to here. So we need to determine the area of that triangle. All right, now if you need to turn it on its side, I'm going to act like this is my base. So from here to here is B. And I need this piece right here, that is my H. Okay? Now, hopefully B is easy. B is the length from the origin to that other intercept, which is 8. That is the base. Now, the height is what's going to be tricky. Okay? I need this distance. This distance is the same as this distance down here. That distance is an x value along the x-axis at which the point at the intersection of both of those lines is right there. So therefore, if I were to find this x, which corresponds to where these two lines intersect or where the lines are equal, then I could find this x value for my height. So I know this is a little bit tricky, but it does incorporate intersecting lines, perpendicular lines from last section, as well as throwing in some area here. So what I need to determine is the x value at which these two things are equal. That means I need to take my 1/3 x plus 8 and set it equal to the other line, in this case the blue line that we found perpendicular to be 3x. Now, if I need to solve for x, I got to bring this guy over. So I'm going to add 1/3 x and add 1/3 x. So this goes away, leaves me 8 equals. Now, if I do 3 plus 1/3, 3/1 plus 1/3. I have to have a common denominator. Now, have your calculator help you out with this. You don't have to do it by hand. This becomes a 9/3 plus a 1/3. So when we talk about fractions, I say keep that bottom of the thirds, add the top, or change the top. I end up getting a 10/3 x when I do that. And at the very end here, now to solve for x, notice this is multiply. You can divide by 10/3 and divide by 10/3. But when you divide by a fraction, the rule is to multiply by the reciprocal. So I'm going to choose to multiply by the reciprocal to start with, because this 3 and that 3 is canceling, that 10 and that 10 is canceling, leaves me just an x on the right side. So what I do to one side, I must do to the other. Whoops, wrong one. Not 10/3, I multiply by 3/10, excuse me. So we're going to multiply by 3/10. And again, you can do this piece in your calculator if you want, or you can do it over on the side. So if I do 3/10 times 8/1, I can cross cancel here a 2. So take out a 2, gives me a 4 and a 5. Now go straight across, because there's nothing else to cross cancel here. And we get a 12/5. So x is equal to 12/5, which is approximately, well, not approximately, is exactly 2.4. And do I look like I'm 0.4 with all my drawings and scribbles in here? Yes, that intersection should be a little past 2. So 2.4 is reasonable. So you can do 1/2 times 8 times 12/5, 1/2 times 8 times 2.4. Whatever your little heart desires, but when I run this through, 1/2 of 8 gives me 4. When I multiply 4/1 times this, go straight across, I get 48/5. And again, that could be your final answer. You could also write your final answer as what? 9 3/5 would be an answer that would be acceptable. Or, gosh, sorry. Why this does this? Come on. Okay. So 9 3/5, I guess it's not coming off. 9 3/5 would end up being 9.6 as well. So any of those would work. 12/5. Let's see if that'll exit. Okay, it's not going to exit. So, sorry. Oh, there it goes. Okay. So let's scroll down. Sorry about that. All right, so 9 3/5, or you could write that as 9.6 as well. No unit here, so we don't have to worry about putting a unit on. If it was like centimeters, it would be centimeters squared, etc. Okay. All right, very good. So those are some applications that I'll ask you to kind of practice some of those. They may look similar. They may look a little bit different. But do practice those and kind of start using those skills that you can use to problem solve. So next thing we're going to get into is some regression lines, which is very similar to some real world problems, although we get to kind of create the line and project that equation according to some points in the middle of some data sets. So until next time.